So we're going to look at completing the square when the b value is an odd number. Now the actual process is the same, it just becomes a little bit more difficult when you've got fractions involved. So I'll work through question 5b for you. So we're going to start off exactly the same way, and you've got writing down the first two terms, and then you half and square that. Now when you half 7, it becomes 7 on 2. Let's stick to fractions, please. So 7 on 2, and then square 7 on 2 becomes 49 on 4. So plus 49 on 4 and minus 49 on 4 plus 2. Alright, now I know we don't like fractions, but I keep harping on about the fact that we need to be working with fractions all the time, so we need to polish up. So it's exactly the same process. So the square root of x squared is x. The square root of 49 on 4 we know was 7 on 2. So that becomes 7 on 2, and the sign comes from there. So that's my first bracket. Now I've got minus 49 on 4. 2 would be 8 on 4. Alright, so keep going. I've got x plus 7 on 2 all squared. Minus 49 plus 8 is minus 41 on 4. Now 41 on 4 is not a perfect square. 4 is, 41 isn't. So I'm going to take the square root. So x plus 7 on 2 all squared minus the square root of 41 on 4. Okay, all squared. And if I come over to my working out bit over here, we'll see that that's the square root of 41 on the square root of 4, all squared. Alright, so square root of 4 is 2. So it's actually the square root of 41 on 2, all squared. So let's just write that there to make it nice and tidy. Square root 41 on 2, all squared. I now have the difference of two squares. Alright, let me put my equal signs in, and so it's the first term plus the second plus square root 41 on 2, and then it's x plus 7 on 2 minus square root 41 on 2. So you can see the process is the same, but now we're just dealing with those dreaded fractions. So these are the hardest ones to do. If you can do this, you're doing pretty well. So ax squared plus bx plus c. We're now looking at when a doesn't equal 1. So we're talking about non-monic. And it's not that we can even take a common factor out for these ones. You can see with 10b that there is no common factor there. We can't take that 3 out to make that monic. So what do we do? Well, in fact, we still take it out as a common factor. So what's going to happen here is if you take the 3 out the front, you're left with x squared plus, now that becomes 4 on 3x when you take 3 out as a common factor. If you were to multiply that back out again, 3 on 1 times 4 on 3, you'd end up back with 4. So because I'm taking 3 out, alright, 3 divided by 3, if you like, is the same thing as 1. And it's the bit inside that now I'm going to factorise by completing the square. You can see that I have actually made it monic. Alright, so where do I go? Write down the first two terms. So the first two terms are, and that 3 will stay out the front all the time, x squared plus 4 on 3x. Now we need to halve that and square it. How do you half 4 on 3 and square it? Well, 4 on 3 times a half, and then you square it. So 4 over 6 all squared is 16 on 36. So plus 16 on 36 minus 16 on 36, and then don't forget the minus 1, 3 on 3. Okay, 3. Now, again, the process is the same. It just becomes a bit more complicated. So the square root of x squared is x. The square root of 16 on 36 is 4 on 6. Okay? And the sign comes from the middle here. Alright, and that's our square term. And then you've got minus 16 on 36. And 1 is minus 16 on, sorry, we'll take that back. That's minus 36 on 36. Need to get a common denominator there. So minus 16 minus 36 minus 40 minus 52 on 36. Again, all of that is inside the 3. Next step in the process, we're going to look at this term here and work out whether or not that is a perfect square. And it's not. 52 is not a perfect square. 36 is. So if I was going to do some work with that, and I'll do it in a different colour here, you've got the square root of 52 on 36, all squared is what we want. And of course 36 is 6, so it's 52 on 6. All squared. So coming back over here, 3, and I've got x plus 4 on 6 all squared minus the square root of 52 on 6 all squared. Square root and square. Last step, 3 bracket first term plus second term. First term minus second term. Probably what you should just do a scan for now is to see whether or not you can simplify any of those fractions in the brackets. Does 52 have any factors where 1 is a perfect square? In fact, it does. The square root of 52 is 4 times 13. So let me just move that up a little bit so that we've got some working room. And so we've got the square root of 52 equals 4 times 13, which would be 2 root 13. And it's on 6, so that will cancel with that, and we're left with root 13 on 3. 4 on 6 also simplifies, so let's just tidy this up now, and we've got 3 x plus 2 on 3 plus root 13 on 3 x plus 2 on 3 minus root 13 on 3. So you can see a lot of work. They are the harder ones, but the process is the same. They just need some practicing.